Okay, so this is my video reflection for the Core 9 robot project. So basically my project is a catapult, and it can shoot at a random distance. So there are three functions in the robot. So the first function is the joystick, as you can probably see in one of these images, controls the forwards and backwards motion. You can push it a little bit forwards and it will go like a slower speed, and then if you push it further forwards, it will go at a faster speed. It's the same in reverse. If you push it back the joystick back a tiny bit, I'm talking about the y-axis, not the x-axis. But so if you push the y-axis back a bit, it goes slower. Further, it goes faster. This is our A-level one. Our second function is a bumper. So it's a momentary switch, and when you press, when it's pressed, or so when it hits into an object, the robot just stops. So the joystick is fairly unique. We used a pin release mechanism, but using a motor which controls rotary motion, the first gear, that converts to linear motion, which is the worm gear. So yeah, it was just fairly unique design. We didn't see it in many other projects. The third function is a release mechanism for the firing, the catapult arm. So when you push the joystick to the left, a motor turns a gear, which turns a worm kind of gear, and that pulls back a pin which is holding the catapult arm in place. This causes the catapult to fire.
Damn it.
And the last and probably most complicated function is the actual distance sensing itself. So the distance sensor senses the distance, and then when the joystick is not being pushed forwards or backwards in the y direction, when it's just idle, it moves backwards or forwards depending on its distance until the robot is 100 centimeters away from the object it's trying to shoot. This is around, it's probably a bit shorter, but it's around the distance that the catapult would actually shoot. So in effect, you can shoot at a random distance, but the power won't be adjusted, it will be the distance to the object. So through our engineering process, we encountered some bumps along the way. The project itself started out fairly slow. We still weren't really sure on which method to go through. We were kind of still in the idea phase, and it took actually a while to build the chassis and all the parts around it. Once we finished the catapult arm, though, the process speeded up because we could test a lot more things like with the distance sensor and the motor and all that. So yeah, the process my attitude towards the engineering process changed because I realized how precise engineers have to be. They have to build axle parts very perpendicular to what the salt that they go through. They have to calibrate distance sensors correctly. We had a problem where the distance sensor was reading weirdly, and it was because a metal piece was sticking up just too much, and the distance sensor was reading that part. So that's we had to fix that with just a piece of paper, but we had to be precise about that. I also learned how satisfying it can be to finish creating a project after spending so much time on it. It can be very nice to see it all come together. I think, but one of the most important things I learned is how creative and involved in problem-solving engineering is. We had to think of so many designs and think outside the box to come to the design we finally chose, and it's a really nice creative process. I think the biggest challenge Ethan and I faced was the distance sensing one. We had to create the B-level problem, which included the fact that our catapult had to shoot to a random distance. So it took a bit of brainstorming with Mick's help, but we eventually decided to make the robot itself actually move rather than the power change. And that took a bit to get to, the idea, and then it took longer to just execute that. It was hard implementing that into the only input we have, or one of the only inputs we have, which is the joystick. So we were originally thinking of which direction would activate this thing and how would that be interfered by other manual inputs. And so we decided to just have the robot distance read when the joystick is in the idle position. This shows in a couple of our demonstration videos where I'm the one demonstrating and I put the joystick in the idle position and it starts going backwards or forwards. But I think I'm quite proud of how it came out. Ethan and I didn't really add many revisions. We moved the Arduino and the breadboard to the platform on top of the chassis, and also added an onboard battery. We had mostly done our ideas before we started building, so there wasn't really much to change. So another way some of my classmates approached the project was by doing a flywheel system. Cole and Nico designed basically the motor would control two flywheels to propel the ball. Well, I'm not sure how well this worked. The idea seemed really interesting. A lot of other people used a boot mechanism, like a kind of a golf ball, like you just whack it and it flies. And I thought that was cool, but they couldn't shoot as far as ours did. So yeah, overall, I'm really satisfied with how our project turned out. I just like the design, the aesthetics. They ended up being a lot better than I expected. And I think just generally it looks a lot better than other catapults and even other robots in the class. I don't think I would have chosen another way to do it. We early on we were thinking of doing a crossbow, but we decided against it because we wanted to do the B level one. The system is fairly compact as well, which I like. We didn't really receive any constructive criticism for our project, but a lot of people complimented us and said our project looked cool, which I appreciate. One of the most important things that I learned throughout the project is how to debug the code. For instance, a large skill that is a part of this is that Mick taught me is to check that sensor is actually sensing something. That way you could tell if it's something's wrong with the sensor or something's wrong with the output. That really helped with my code project. And in general, just like the creativity and problem solving, I talked about this earlier, but I still think it's a really important part of engineering. So that's all I took from the core project, and I really had fun doing it. It was lots of work, but I enjoyed it. So thank you for listening to and watching to my reflection. And yeah,